J video presentation. Today I'll be presenting on a topic in MAT183, which is application of differentiation. Hello, my name is Ariel, Redondo, Changi, and Michael from AS120R2.
Hello, my name is Siti Nurhafiza binti Sofi from AS120R2.
We have taken an interest in the topic application of differentiation. Now, what is differentiation? Basically, it is about figuring out how one variable changes with respect to another variable. As an example, for a change which is a constant, such as a straight line, this concept will be quite similar to a slope. Let's say if x is a variable and y being another variable, the rate of change of x with respect to y is stated as dy over dx, also known as derivative of y over derivative of x. These are rate of change and mean value theorem, just to name a few. First up is rate of change. Rate of change of y or x with respect to t is written as dy or dx over dt, where dt stands for derivative of time. As a matter of fact, time plays a very important role. Rate of change can be obtained through differentiating both sides of the expression with respect to time, and the method used is implicit differentiation. Second topic for differentiation is mean value theorem. It is stated that if a function f is continuous at closed interval ab and differentiable on the open interval curved bracket ab, then there exists a point c in the open interval curved bracket ab, such that derived function c is equal to the function's average rate of change over closed interval ab. Differentiation as a whole can be applied in real life and is found in various occupations. It is used to calculate the profit loss in business through the use of graph, checking temperature variation, and to also find the range of magnitude of earthquakes. For this video presentation, both of us chose to put our focus on applied maximum and minimum problems. I will now explain about one of the problems people may encounter in their daily life and how derivative can be used to solve it. The situation that we have chosen is regarding construction or restoration of a fence surrounding a tennis court. The reason why we have chosen this situation is due to it being somewhat similar to daily tasks one might find outside of their work. Now, on to the question itself. The area of rectangular tennis court is around 700 meters square. The construction contractor is tasked with replacing and repairing fences surrounding the tennis court, which was damaged due to it being hit by large debris during a recent storm. The fence which needs to be replaced on one side costs around 25 ringgit per meter, and on the other three sides, which needs repair, costs around 10 ringgit per meter. The contractor will then need to find the dimensions that will minimize the cost and the minimum overall cost. Now for the first question. The objective is to find the cost. First, write down the equation 25x plus 10y plus 10y plus 10x and total it up. This shall give us 35x plus 20y. Next, we will write down xy equals to 700. The 700 comes from the given area. X is then moved to the right side of the equation, which will be y equals to 700 over x. This equation is quite important since it will be used in the solution for question B. Now for the final part, 700 over x will be substituted into the equation 35x plus 20y. The answer shall be 35x plus 14,000 over x. And just like the previous equation, 35x plus 14,000 over x will be used in the next two solutions. The second question wants us to find the dimension to minimize the cost. In step 1, we need to find the first derivative, and the equation 35x plus 14,000x to the power of -1 will be used. After differentiating the equation, it shall be 35 minus 14,000x to the power of -2, which will be written as 35 minus 14,000 over x squared. For second step, the derivative dc over dx will be equal to 0. Now we are left with the equation 35 minus 14,000 over x to the power of 2 equals to 0. X squared will then be moved to the left side, with 14,000 being divided by 35. This leaves us with x squared equals to 400. Square root of 400 is 20, which is the answer for x. In the final step, 35x plus 14,000x will be derived twice. Instead of deriving from the start, we can just use the first derivative, which is 35 minus 14,000 x to the power of -2. This can help us save time. The second derivative for 35x plus 14,000 over x is 28,000 over x cubed. Since x equals to 0, it will be substituted into the previous function. The answer for it will be 3.5. This proves that x equals to 20, which is the minimum value. Lastly, 20 is substituted into x in y equals to 700 over x, which was a function from the first solution. This gives us y equals to 35 meter. The solution for this last question is quite short. To get the minimum cost, 20 is substituted into x in 35x plus 14,000 over x. The final answer shall be 1,400 ringgit. In conclusion, differentiation has been used effectively to solve this applied minimum problem which occurs in real life. We were able to solve 3 questions related to cost and minimum dimension. There is no doubt that similar problems regarding dimensions, distance, and cost can be solved using similar steps. To summarize what we have explained in the video, there are various subtopics for application of derivative which are heavily used in real life, especially in physics. This was also shown to be quite useful in construction and structural engineering. Last but not least, application of minimum and maximum is used to find minimum or maximum value of a particular quantity, with the given problem being related to cost and dimension of the fences. Before ending this video, I'd like to thank Siti Nurhafiza for her contributions in video editing, general workflow plan, finding sources, and assisting me with the scripts. And I suppose that's all from us. Thank you.